Hello, this is Mr. Stansbury. I'm going to take you through the notes on the Fundamental Theorem of Algebra. At the end of this, you should be able to say, I can find the complex roots of polynomials and complex solutions to polynomial equations, and I can find all the roots of a polynomial using synthetic division. All right, so I'm just going to go through some examples here and call it good. All right, find all the roots of the polynomial equations. So normally we can go through and try to factor, but look, we're starting with x cubed. So we're going to want to go through and do our synthetic substitution, right? So all the factors of 14. So possible zeros are going to be, let's see, factors of 14, 1 and 14, right? So plus and minus 1, plus and minus 2, plus and minus 7, and plus and minus 14. Okay, so we'll go through and do our little synthetic substitution. Away we go. And we really only need to find 1 and then see if we can factor it after that. So bring the 1 down. 1 times 1 is 1, plus 7 is 8. 1 times 8 is 8, plus 2 is 6. 1 times 6 is 6, plus negative 14 is negative 8, right? So that doesn't work. Let's see, negative 1, bring all these 1s are just going to come straight down here, so we might as well just draw these all in here. Negative 1 times 1 is negative 1, and 7 is 6. Negative 1 times 6 is negative 6, and negative 2 is negative 8. Negative 1 times negative 8 is positive 8 plus 14 plus negative 4. Oh, yeah. 8 minus 14 is negative 6, so that doesn't work. 2 times 1 is 2, plus 7 is 9. 2 times 9 is 18, minus 2 is 16. 16 times 2 is 32, and negative 14 does not give us 0. So that's all we've got to figure out is if this equals 0 over here or not. Negative 2 times 1 is negative 2, and 7 is 5. Negative 2 times 5 is negative 10, and negative 2 is negative 12. Negative 2 times negative 12 is 24, and 14. Negative 14 does not give us 0. Right? So on to 7. 1 times 7 is 7, plus 7 is 14. 7 times 14 is a big number. 98. 98 times 7 is a really big number. Minus 14 is not going to give us 0. Negative 7 times 1 is negative 7. And negative 7 and positive 7 gives us 0. Negative 7 times 0 is 0. Plus negative 2 is negative 2. Negative 7 times negative 2 is positive 14. Minus 14 gives us 0. So one of our factors, one of our zeros is going to be negative 7. So we're going to have negative 7 for x plus 7 gives us 0. And then the leftover piece here is going to be 1 x squared plus 0x minus 2, and both of these have to equal 0. So we can actually just go through, this does not factor out, so we can just go ahead and solve that, right? So x plus 7 has to equal 0, x squared minus 2 has to equal 0. So subtract 7, x equals negative 7 like we just found, and then add 2 to both sides. X squared is 2, so we square root both sides, and we get that x is going to be root 2 and negative root 2. So those are our 3 different answers for that one. All right, let's try B here. Okay, so our possible zeros are, let's see, factors of 6, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. Okay. Okay, so here we go. Now notice we have x cubed. There's no x squared, so we got to make sure you put a 0 in there to hold the spot, right? So we're going to bring all these 1s down. 1 times 1 is 1, plus 0 is 1. 1 times 1 is still 1. Plus negative 7 is negative 6. 1 times negative 6 is negative 6, and positive 6 give us 0. So one of our possible zeros is 1. So let's rewrite it because we might be able to figure it out. So we've got x which is 1 minus 1 gives us 0. And the leftover is going to be 1x squared plus 1x minus 6. So then we could just go through and we could factor this, or you can even use the, we could just keep going to see what we can find, what other factor we can find. So you can factor it from here. I'm just going to keep going on this and then see what we end up with. Okay, so negative 1 times 1 is negative 1, and 0 is negative 1. Negative 1 times negative 1 is 1, plus negative 7 is negative 6. Negative 1 times negative 6 is 6. 6 plus 6 is 12. That doesn't work. So negative 1 does not work. 2 times 1 is 2, plus 0 is 2. 2 times 2 is 4. Minus 7 is negative 3. 2 times negative 3 is negative 6, and positive 6 gives us 0. So there's another factor. So now we can get rid of this. Right, because now we know that one of these other factors here is 2 is our x, minus 2 is 0, right? And then we can just keep going to figure out what the last one is, since we're kind of moving along anyway. Negative 2 times 1 is negative 2. Negative 2 and 0 is negative 2. Negative 2 times negative 2 is 4. 4 minus 7 is negative 3. Negative 2 times negative 3 is 6. 6 and 6 is 12, so that does not work. If we try 3, 3 times 1 is 3, plus 0 is 3. 3 times 3 is 9, minus 7 is 2. 3 times 2 is 6. 6 plus 6 is 12, so that doesn't work. Negative 3 times 1 is negative 3, and 0 is negative 3. Negative 3 times negative 3 is 9, minus 7 is 2. Negative 3 times 2 is negative 6, and positive 6 is 0. So here's our 3 zeros, and we got x plus 3, right? So all of our zeros are going to be, right up here, 1, 2, and negative 3. 1, 2, negative 3. Okay, just like over here. I just didn't write zeros over there, but you get the idea. Okay, let's see. Let's take a look at our next examples. Okay, we have these two here, but before we do that, let's take a quick loops. That's not it. Let's take a quick little comedy break. That's it.
Hey, instead of enjoying this moment, let's take pictures. We take pictures of everyday life and act like we're capturing history. Unbelievable, the cat's asleep. Post that on my Twitter. It's because we have the cameras on our phones. Do we need that? It's not like 10 years ago we were like, I wish I could take a low-quality photo of my dessert. Text it to someone that's not interested. But I can't, so I guess I'll just eat it.
All right. Okay, for each given set of zeros, write the polynomial function that has integer coefficients, a leading coefficient of 1, and the least degree. Okay, so we can write this as negative 7 is our x, plus 7 will give us 0. And then we also have x minus root 2. Now, the only way we're going to get this x minus root 2 is if we had to square root something to get that square root of 2, right? So that means we would have it had to have been an x squared of something, and then we ended up getting 2 over here, right? Because you have, when you square root both sides, we're going to get plus and minus root 2, right? So that means if we have x minus root 2, that means if we got plus and minus root 2, we're also going to have, get rid of this, because I put it in a spot where we need to use our space here. And we've got x plus root 2 as well. Okay, so that root 2 there, that means it's also going to have to include negative root 2, right? So if we multiply this out, I would leave this for the end. Let's FOIL this first part out, well, this second part out over here, the x minus root 2, x plus root 2. So first is x squared, outside is x root 2, inside is negative x root 2, and the last negative times negative is negative, root 2 times root 2 is root 4, which is negative 2, right? And these x root 2 and negative x root 2's cancel out. So we end up with x squared minus 2 for this right here. So then all we have to do then is multiply x plus 7 times x squared minus 2. So we can FOIL that out again. And then away we go, right? So x times x squared, x cubed, x times negative 2 is negative 2x. 7 times x squared is 7x squared. 7 times negative 2 is negative 14. So that means the equation has to be x cubed minus, plus 7x. We've got to write it in order. Plus 7x squared minus 2x minus 14. And that is what f of x would have to equal. Okay? To have those answers. All right, same idea here, except for now what we have to do is we have to do the conjugate on that one. By the way, this is the rational root theorem. That's how we know this works. And this is the complex conjugate root theorem, which is a mouthful to try to figure out. Anyway, so on this here, the negative 3, that's going to be here for our x, so that's going to have to be plus 3. And then we're going to have to multiply this by x minus 1 plus root 5. And our complex conjugate root theorem says that it's also going to have to be x minus, and then you got to do the conjugate of this here, which is 1 minus root 5. And then we got to FOIL this whole thing out too, right? Which leave that x plus 3 for the end, and we'll do these here first. And it's going to look kind of messy at the beginning, but it will clean up nicely. X times x is x squared. Outside, that's going to be negative 1 minus root 5 times x. We'll just leave it like that. Inside, let's see, yeah. Wait, I messed that up. Hold on a second. Multiply x by a negative, that's negative x, and then we got 1 minus root 5. Let's write it that way. I think that'll make a little bit more sense. And then inside is, let's see, negative 1 plus root 5 times x. So that's negative x 1 plus root 5. And then the end is going to be negative times a negative is a positive. And then we've got 1 plus root 5 times 1 minus root 5, which guess what? We get to do another little quick FOIL on this one as well. You're like, what the heck? Yeah, this one's weird. 1 times 1 is 1. 1 times negative root 5 is negative root 5. Root 5 times 1 is root 5. And then positive times a negative is a negative. Root 5 times root 5 is root 25, which simply is negative 5. Those two cancel each other out, and we got 1 minus 5, so that is negative 4 is what this last piece is over here, right? So we're going to combine those all together. We got x squared, and then we've got this here. Let's simplify these two. Negative x times 1 is negative x, and then we've got negative x times negative root 5 is plus x root 5. And then this one here, negative x times 1 is negative x, and then negative x times positive root 5 is negative x root 5. So those are going to cancel each other out when we add them together. So we have x squared minus 2x minus 4 is what this big mess ends up to be. And then we still have to multiply it by x plus 3. So I'm going to do this, put it underneath here. 3 times 4, negative 4 is negative 12. 3 times negative 2x is negative 6x. 3 times x squared is 3x squared. x times negative 4 is negative 4x. X times negative 2x is negative 2x squared. X times x squared is x cubed. So we get x cubed minus plus x squared minus 10x minus 12 is what f of x equals. That is, I know that's a bit of a doozy there, but that's just some of our fundamental theorems of algebra. All right? Okay, if you have any further questions on this, please feel free to ask in class. Thanks.